straight lines. At the end of this lesson, you will be able to explain straight lines, discuss a few important formulae related to straight lines. Introduction to straight lines. Hello students, welcome to our class. I am here to teach you the chapter straight lines. Let's begin our class. First, can anyone tell me what is a straight line?
Simply, a straight line is a line which is not curved or bent.
Good. In a mathematical term, a line is simply an object in geometry that is characterized under zero with objects that extends on both sides. So, a line that extends on both sides till infinity and has no curves is called a straight line. Where have you come across straight lines in your daily life?
Zebra crossing line, track of bowling pin ball.
Yellow lines in the middle of the road, pillars of a building.
Good examples. Now, imagine a situation that you build 2 dog houses in the garden. You want to build a small bridge path between the 2 dog houses and let the houses for the pets be at points A and B. The requirement is that it must create a straight line path between the 2 dog houses. Also, you wish to build a play area for them where they meet and play the whole day. And you want to keep the play area at point C, which lies between A and B, in the ratio of 3:2 from the points A and B, respectively. Assume you have the map of your garden and you know the coordinates of the houses of dogs. With these details, how will you find the distance between the 2 points, say 2 dog houses? And how will you find the position of C, say the position of the play area? To answer these questions, we need to learn what a straight line is and a few important formulae related to it. Let's discuss those now. Formulae related to straight lines. Before learning the formulae, let us first recollect the points on the location of points. Consider the points 6, -4 and 3, 0. How will you locate these points in the xy plane? Let me recall it now. First, place the point 6, -4 at 6 units distance from the y-axis measured along the positive x-axis and at 4 units distance from the x-axis measured along the negative y-axis. Similarly, place the point 3, 0 at 3 units distance from the y-axis measured along the positive x-axis and has 0 distance from the x-axis. In this way, we can locate the points. Next, let us see a few important formulae related to straight lines. Consider 2 points, P of x1, y1 and Q of x2, y2 in a line. Now, how will you find the distance between the points P and Q? To find the distance, you have to know the coordinate points of P and Q, say x1, y1 and x2, y2, respectively. If you know the coordinate points, then you can use the formula square root of x2 minus x1 the whole square plus y2 minus y1 the whole square to find the distance between them. Thus, using this formula, we can find the distance between any 2 points. Consider a line whose endpoints are A of x1, y1 and B of x2, y2. Imagine a point C divides the line segment internally in the ratio m:n. Now, how will you find the coordinates of a point dividing the line segment joining the points A and B internally in the ratio m:n? The coordinates of a point dividing the line segment joining the points A and B internally in the ratio m:n are mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. If m is equal to n, then the formula used to find the coordinates of the midpoint of the line segment joining the points A and B are x1 plus x2 by 2, y1 plus y2 by 2. Next, consider the triangle whose vertices are x1, y1, x2, y2 and x3, y3. How can you find the area of the triangle if the vertices are given? The area of the triangle whose vertices are x1, y1, x2, y2 and x3, y3 is 1 by 2 into modulus of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. If the area of the triangle ABC is 0, then 3 points A, B, and C lie on a line. That is, they are collinear. Hope you got to know the formulae. For a better understanding, let us solve a few problems based on these formulae discussed. Problems based on straight lines. The first problem we are going to discuss is to find the distance between the points displayed on the screen. Now, tell me the formula to find the distance between any 2 points.
The formula is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square.
Okay. Now, let us consider the first subpart. From the first subpart, let x1 be 3, y1 be 2, x2 be minus 2, and y2 be minus 3. On substituting the values in the formula and simplifying, we get the distance between P and Q as square root of 50. On finding the square root, we have the distance PQ as 7.07 approximately. Next, let us consider the second subpart. From the second subpart, let x1 be 6, y1 be 4, x2 be minus 5, and y2 be minus 3. On substituting the values in the formula and simplifying, we get the distance between P and Q as square root of 170. On finding the square root, we have the distance PQ as 13.04 approximately. Now, take the third subpart. Here, let x1 be 1, y1 be 7, x2 be 4, and y2 be 3. On substituting the values in the formula and simplifying, we get the distance between P and Q as square root of 25. On finding the square root, we have the distance PQ as 5. The next problem is, find the coordinates of the point which divides the line segment joining the points 4, minus 3 and 8, 5 internally in the ratio 3:1. Let P of x, y be the required point. Now, tell me the formula to find the coordinate points of P.
The formula is P of x, y is equal to mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n.
From the given coordinate points, we have the values x1 as 4, y1 as minus 3, x2 as 8, and y2 as 5. Also, we have the values m as 3 and n as 1. On substituting these values in the respective places of the formula and solving the terms, we get the required point x, y as 7, 3. Next problem is, find the coordinates of the point which divides the line segment joining the points 4, minus 3 and 8, 7 internally in the ratio 3:3. Let P of x, y be the required point. Now, tell me the formula to find the coordinate points of P.
Since m is equal to n, we can use the formula P of x, y is equal to x1 plus x2 by 2, y1 plus y2 by 2.
From the given coordinate points, we have the values x1 as 4, y1 as minus 3, x2 as 8, and y2 as 7. On substituting these values in the respective places of the formula and solving the terms, we get the required point x, y as 6, 2. The last problem is, find the area of a triangle whose vertices are as shown. Let the coordinate points be A, B and C as displayed on the screen. Now, tell me the formula to find the area of the given triangle.
The formula is 1 by 2 into modulus of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2.
And, from the vertices, we have the values x1 as 1, y1 as minus 1, x2 as minus 4, y2 as 6, x3 as minus 3, and y3 as minus 5. By substituting the known terms in the respective places of the formula, we get the equation as displayed on the screen. On simplifying the terms, we get the area of the triangle as 24. So, the area of the triangle is 24 square units. Summary. Thus, we have come to the end of our session. Can anyone summarize today's class?
Sure, ma'am. A line is simply an object in geometry that is characterized under zero-width objects that extends on both sides. The formula to find the distance between any 2 points is given as displayed on the screen. The formula to find the coordinates of a point dividing the line segment joining the points A and B internally in the ratio m:/n is given as displayed on the screen. If m is equal to n, then the formula used to find the coordinates of the midpoint of the line segment joining the points A and B are given as displayed on the screen. The formula to find the area of the triangle, whose vertices are x1, y1, x2, y2, and x3, y3, is given as displayed on the screen.
Conclusion. Hope you are all clear about the formulae related to straight line discussed so far.
We are clear now, ma'am.
Now, using the distance between 2 points and section formulae, we can find the distance and the coordinates of a point dividing the line segment joining the points. Good. And, in the next few classes, we shall continue to study the properties of a straight line. The first property is the slope of a line. To represent a line algebraically, slope is essential. So, let's discuss the slope of a line in our next class.